Welcome to another episode of Agentic AI. Today, we're tackling a question on many engineering leaders' minds. Why are LLMs and coding copilots failing to deliver the promised value? We've all heard the bold claims AI will replace developers, 10 times productivity gains, software development democratized for all. It's an exciting narrative, one that paints these AI coding assistants as almost magical solutions to our software engineering challenges. But if you've been watching the reality on the ground, you know the story isn't playing out quite as advertised. In fact, in real engineering projects, these tools are falling short in very practical, important ways. Let's start at the beginning. Over the past couple of years, large language models and code copilots have been marketed as game changers. The promise is tantalizing. Write a prompt, get functioning code, have an AI pair programmer that finishes the tedious parts for you. It's the kind of promise that makes engineering managers and CTOs sit up and take notice. Who wouldn't want to ship features faster, squash bugs automatically, maybe even reduce headcount needs? The marketing suggests a near future where you describe what you want in plain English and the AI does the rest perfectly. No wonder so many leaders have felt pressure to get on the AI train or risk being left behind. Yet, when we look beyond the marketing and actually examine code written by these AI copilots, a very different reality emerges. I recently had the chance to deeply analyze a real code base that had heavily incorporated AI generated code. Think of it as a peek behind the curtain of what Copilot and similar tools produce in a production app. The findings were eye opening. On the surface, the code ran and the features mostly worked. But as we dug into the implementation, we kept finding things that a seasoned engineer would consider red flags. For example, we encountered magic numbers and hard coded values sprinkled everywhere. One function truncated a string to 40 characters with no explanation. Why 40? In another spot, a timeout was set to 120 seconds arbitrarily, not based on any API limit or UX research, just a number that looked reasonable. These weren't one off oddities, they were patterns. It was as if the AI plucked seemingly plausible values from thin air because they appeared often in training data, not because they made sense for the product's requirements. A human engineer designing that feature would have asked, what are the real constraints? Should that limit be 40? Or is there a reason behind it? But the AI doesn't ask why, it just inserts a number that fits a pattern. This hallucinated logic leads to software that technically works but has no grounding in the real world context. It's fragile. If tomorrow the requirements change or an edge case appears, you realize there was never any rationale to guide a proper adjustment. We also found no architectural consistency in how certain tasks were done. The codebase had three different ways to perform the same state update in a UI component. In one place, the AI generated code checked a mounted flag before calling setState. In another, it checked inside the setState call. Elsewhere, it didn't check at all. Each snippet individually was functionally correct, but together they painted a picture of inconsistency that no human team would intentionally choose. It's the kind of thing that creeps in when there's no higher level understanding enforcing a pattern. In a well run software project, an architect or lead developer would say, this is how we handle state updates across our app, and you'd adhere to that for clarity and maintainability. The AI, however, has no sense of the big picture. It writes each piece of code in isolation, pattern matching what might be a valid approach, unaware that five other files solved the same problem in five different ways. Over time, That inconsistency becomes a maintenance nightmare. Harder to debug, harder to extend, and certainly harder to trust. Then there were the race conditions and timing bugs lurking under the surface. In an initialization flow, the AI had inserted multiple calls to notify listeners and update loading flags, trying to be helpful. But it did so in slightly different ways in different places, sometimes returning a value after notifying, sometimes not. In one JavaScript snippet, it set a 2-minute timeout to reset a payment process, but with no clear reason or coordination with other parts of the system. If you're an experienced engineer, alarm bells are probably going off in your head. Timing and concurrency issues are some of the trickiest bugs to catch. You need a solid understanding of how data flows and how users might interact with the app in real time. The AI doesn't truly grasp the concept of time in code execution or the subtle interplay of asynchronous events. It only sees patterns of text. So it introduces subtle bugs that look like correct code but might cause a failure when two things happen at once or a network call returns slower than expected. These are exactly the sort of bugs that keep engineers up at night. And here they were proliferating because the assistant simply didn't understand the concept of synchronizing state across a complex journey. One more striking theme from that analysis: error handling or lack thereof. The AI had diligently added try catch blocks around many operations. At first glance, a good practice. But each catch block did almost the same thing: print a similar log message and return a generic error result. It was copy pasted error handling logic everywhere, dozens of times, with no abstraction and no deeper consideration. If a human junior developer wrote code like that across an entire code base, a senior engineer would pull them aside and explain how to consolidate logging and manage errors more gracefully. You'd maybe design a single error handling function or at least ensure the messages and recovery strategies are consistent. The AI didn't do that. It can't learn or refactor from one instance to the next. It just reproduces the pattern it saw. Each function gets its own verbose error catch because in training data, that pattern appeared often. The result was not only a lot of redundant code, but also a missed opportunity. None of those error handlers actually help recover or improve the user experience. They were just repetitive logs. Real engineering isn't just about catching exceptions, it's about deciding what to do with them. Maybe retry the operation, prompt the user, fall back to a default, or at the very least, aggregate the error for monitoring. That kind of higher level decision was entirely absent from the AI generated portions. The code had errors caught but not truly handled. By now, a picture should be forming. In each of these examples, the arbitrary constants, the inconsistent patterns, the superficial error handling, the root cause is the same. These AI copilots lack understanding. They don't understand why the code is needed, how it will be used in the broader system, or what the actual problem is that we're trying to solve for the end user or the business. They generate code that looks right in a textbook sense or according to common coding patterns, but software engineering is much more than writing code that looks right. It's about writing the right code, code that aligns with real requirements, works in concert with other parts of the system, and can be maintained and extended over time. And this brings us to a critical disconnect. If these AI models are so flawed in practice, why do they seem so impressive in demos and benchmarks? You've probably seen the headlines: Model X achieves 90% on a coding challenge, or LLM passes all tests for a data structures exam. Those achievements are real in their context. Today's best models can indeed produce working code for well defined problems, sometimes in a single shot. But here's the key: benchmarks and toy problems measure a sliver of what matters in real world engineering. A typical coding benchmark might ask the AI to implement a known algorithm or solve a self contained puzzle with input output examples. If the AI produces code that passes the provided unit test, we declare success. That's fine for evaluating raw code generation capability. However, production readiness doesn't live in that world of perfect specifications and isolated functions. In a production code base, requirements are often vague or evolving, and simply making the test pass doesn't guarantee your software will hold up under real conditions. Engineering leaders care about things like: does the code handle edge cases? Is it secure against malicious inputs? Will it scale with 10 times more users? Can another engineer easily understand and modify it next month? None of those questions are directly addressed by a benchmark that only checks if an output is correct for a few static cases. So, when a vendor boasts about benchmark prowess, it doesn't tell you how their tool's output will fare in your integrated, messy live system. In fact, there's a danger that benchmark based success gives a false sense of security. Leaders might think, well, if the AI can solve these tricky lead code problems or generate an e commerce demo app in 30 seconds, surely it can handle our code base. But high performance on benchmarks has not translated to dependable performance in production environments. We've seen AI written functions that technically fulfill a narrow task yet cause cascading issues when plugged into a larger application. Why? Because the AI isn't actually reasoning about the system, it's predicting text that statistically looks like good code. It doesn't truly know what an online store or a banking app or a healthcare system requires beyond syntax and patterns. So it might do just enough to pass a simple test, but not nearly enough to be safe and sound when deployed. Benchmarks measure if the code works in principle. Engineering demands code that works in practice under real conditions all the time. Now, this isn't to say these AI tools have no value, they absolutely do. But to unlock that value, we need to confront why the current framing is misleading, especially for engineering leaders and decision makers. When the narrative is this tool can replace a junior developer, or soon we won't need as many engineers, it frames AI as a way to cut corners or even cut people. I want to address this directly. That framing is not only misleading, it's counterproductive. It sets up unrealistic expectations and worse, might tempt some organizations to underinvest in the very human expertise that is actually more critical than ever. Imagine a CTO proudly telling their team or board, we're adopting AI coders so we can move faster with fewer engineers. This mindset might lead to rushing AI generated code into products without proper review or scaling back hiring and training of talent. But as we've explored, the code coming out of these tools often requires deeper engineering effort to fix and fortify. If you've cut your engineering staff or neglected your architecture thinking, you're going to accumulate a mountain of technical debt. The irony is palpable. Hoping to save time and money, you could end up spending more of both, cleaning up behind an overeager AI. There's also a more subtle misdirection happening. Many tech leaders are focusing on the wrong question. They're asking, when will AI be advanced enough to do everything a developer can do? Or how do we get to a point where we trust AI to handle full projects? These questions make it seem like we're on a straight line of progress. Just a few more model upgrades, and voila, no more need for human engineers. But that's not the reality we're observing. The failures in the AI generated code aren't just minor bugs that will be ironed out with a slightly more advanced model. They stem from a fundamental lack of understanding, a gap that doesn't close simply by training on more GitHub repos or adding more parameters. Put plainly, writing code is not the hard part of software engineering. Understanding what to build, why it should be that way, and how it will behave in all the nuanced situations of the real world is the hard part. So, what's a more honest and useful framing for these AI coding tools? How should engineering leaders, architects, and practitioners really be thinking about copilots and LLM? The first step is to see them for what they truly are: powerful automation for certain coding tasks, and absolutely assistants rather than autonomous agents. In practice, these tools are best used as accelerators for humans, not replacements. For example, an AI assistant can draft boilerplate code or generate the skeleton of a function in seconds. That can save a developer time, letting them focus on the tricky logic or the important design decisions. That's genuine value. It can suggest solutions or alternatives that a human might not have thought of as quickly. Sometimes this surfaces a useful idea, other times it's off base, but it expands the ideation phase. It can even help with things like writing unit tests or converting code from one language to another, which are tasks with well defined patterns. All of that can improve productivity when managed correctly. However, using these tools effectively requires discipline and a clear process. You might set ground rules in your team. Any AI generated code must undergo normal code review, just as if a junior developer wrote it. Think of the AI as an intern with perfect recall of documentation and examples. It's fast and often correct in form, but you'd never let an intern's code into production without a thorough check. Similarly, you use the AI to draft and speed things up, but you always have a human in the loop to validate architecture, ensure consistency with the codebase's patterns, and verify that the solution actually meets the real requirements. In short, you treat the AI as a capable tool, not a free thinking engineer. Another part of a healthier framing is to reset expectations with your stakeholders and teams. Instead of saying AI will let us do the work of 5 people with 2 people, say AI might let each developer handle more grunt work so they can spend more time on creative engineering. The goal is not to remove humans from the process, but to remove tedium from humans so they can apply their brains to the interesting stuff. When you communicate this, you shift from a narrative of replacement to one of augmentation. It's not only more accurate, but it also sets your team up to feel empowered rather than threatened. Engineers should feel like this technology is an assistive superpower in their ID, not a sword of Damocles hanging over their job. Let's also talk about metrics and incentives because those drive framing too. If a vendor or internal team is boasting about how many lines of code the AI generated or how it completed 100 tasks last week, that might sound good superficially. But smart engineering leaders will ask, did those lines of code reduce the overall workload? Or did they introduce 3 new bugs for each feature? How much time did we spend cleaning up or reworking those AI contributions? If the answer is that engineers are spending more time managing AI output than they would writing it themselves, then the tool isn't providing value, it's actually creating overhead. A more useful metric would be something like time saved on scaffold coding that was successfully reused, or reduction in turnaround for prototyping new ideas while maintaining our quality bar. Essentially, measure what helps engineers, not just what impresses on a slide deck. Finally, to reframe effectively, we must be honest about the limitations. There's no shame in acknowledging that current LLMs have serious gaps. It doesn't mean the technology is worthless, it means we know where the boundaries are. For instance, you might openly decide our AI assistant will be used for front end components and test generation, but we won't use it for core security critical code, or we'll use it to get initial code suggestions, but we rely on human architects for the overall design. By drawing those lines, you actually increase the tool's success because you're applying it where it makes sense and holding back where it doesn't. Over time, those lines might move as the tech improves or as you develop better guardrails, but it should be a conscious, evidence based expansion, not blind faith. As we wrap up, the theme here is becoming clear. LLM powered coding tools can make us faster at writing code, but they aren't removing the need for engineering judgment. They're not handling the ambiguity, the context, or the forward thinking that true software development requires. Those aspects remain our distinctly human responsibility. When we embrace that, we stop fighting the wrong battle of human versus AI and start focusing on how humans and AI can best work together to build great software. So, to all the engineering leaders and practitioners listening, take the promises with a grain of pragmatism, but don't ignore the potential. Yes, the promised value hasn't fully materialized, the autopilot isn't ready to fly solo, but if we adjust our course, these copilots can still be incredibly useful crew members on the journey. It starts with seeing them in the right light, not as would be engineers, but as the advanced tools. Because at the end of the day, a hammer, no matter how advanced, doesn't replace the carpenter. And in the same way, an AI coding assistant doesn't replace the engineer, it empowers the engineer. Thank you for joining me in this thoughtful exploration of hype versus reality in AI assisted coding. The conversation around AI in software development is just beginning, and it's crucial that we keep it honest and grounded in real world experience. Remember, the true promise of these tools isn't that they'll magically do our jobs for us, it's that they can free us up to focus on the truly human parts of engineering: creativity, design, strategy, and solving the right problems. In the end, large language models can write code, but only engineers can build solutions. The future of software development isn't about cutting engineers out of the picture, it's about raising our game with AI at our side rather than above us. And I think that's a future worth striving for. Until next time, stay curious and keep engineering with integrity. Because the real magic of AI in coding isn't that it writes the code for you, it's what you and your team can achieve when you wield it wisely.